What is momentum? Momentum is known as velocity multiplied by mass. Its units are kilogram meters a second. The variable is typically written as p. If a 5 kilogram box is going 10 meters a second, then its momentum is 50 kilogram meters a second. What is impulse? Impulse is known as difference of momentum. So momentum 2 subtract momentum 1 equals impulse. Impulse is written with a J. Impulse is also equal to force in newtons multiplied by time in seconds. Therefore, you can get this equation. P2 minus P1 equals force multiplied by time. We can solve multiple equations with this formula. Let's see an example. A 2,000 kilogram car going 20 meters a second forward drives into a wall and comes to a complete stop. If the crash time was 0.5 seconds, what is the average force exerted to the car and in what direction? Okay, so here's the first question here. I just drew a diagram. So number 1 means before the crash, number 2 means after the crash. So we can see the initial velocity is 20 meters a second. The mass is 2,000 kilograms. At the second part here, the mass is still 2,000 kilograms. And now the final velocity is 0 meters a second. So therefore, what direction will the force have to be in? If you started going this way, and then you finished not moving at all, that means the force would have to be in the opposite direction, right? Because that means acceleration would also have to be in the opposite direction. So force is in this direction, okay? Force is in that direction. And then time of the crash is 0.5 seconds, and we're trying to find the average force. So let's use our trusty equation from before. So we have delta P, which is impulse, equals impulse, right? So let's fill this in. Okay, so one of these we can take away right away, and that's VF, because the final velocity is 0, right? So just look back here, see final velocity is 0. So if you multiply 0 by the mass, you're just going to get 0. So I'll just take that one out. So we have negative VI times mass equals V average delta T. So let's fill in for, actually let's rearrange. So we're trying to find V average, so I'm going to move delta T onto the other side here. And then if we fill in all our numbers, you're going to get 20 meters a second times 2,000 kilograms divided by 0.5, which is just going to get you, so this is negative, so I'll just do a negative out there. And that'll all get you 80,000 newtons. So answer equals 80,000 newtons. And then of course you also have to have a direction. So the direction would be backwards, right? Because it's slowing it down, so backwards. There you go. And that's your answer. So in this case, I'm sure whoever was driving the car probably wouldn't survive, because that's a very large amount of force. Example 2. A tennis player hits a 58-gram ball coming in at 10 meters a second towards him at an average force of 50 newtons in the opposite direction for 0.05 seconds. What is the exit speed of the ball? Okay, so I have the two drawings here. So we have number 1 right there, number 2 right there. So the initial velocity is 15 meters a second backwards. Mass is equal to 0.055 kilograms, and that's the same for both of them. And we're trying to find the final velocity. So we know the force is in the forward direction, which means our final velocity is probably going to be in the forward direction as well, but we don't know for sure. We'll be able to tell with whether our answer is positive or negative. So because we made forward positive, if our answer is positive, then the direction's forward, but if it's negative, that means our direction is backwards. So let's write down our trusty equation here. So let's rearrange this. So we're trying to find final velocity. So we're gonna add this. So we're gonna add that on both sides, and then we're gonna divide by mass. So here, actually, I'll do it one at a time. So first I'll add it, and then we're gonna divide by mass on both sides. So divide by mass, and then I'm just gonna erase this here. This is what you're gonna get. So that's gonna be the equation you're gonna use, and then you're gonna fill in all the numbers, and you're gonna get your answer. So now just put that in your calculator. So if you put that in your calculator, you should get about 30.5 meters a second. And then our answer was positive, so this is positive, which means our final answer, so VF is going to equal 30.5 meters a second, and then forward. There we go. And that's our answer.